Hello everyone and welcome back to ThursDev. I'm your host Luke, and today I want to talk about video game engines. If you go way back in the archives of the ThursDev series, I've touched upon the basic description of what a game engine is and what it does, but I've never really gone very far in depth, and I feel like a little knowledge of the engine could benefit many, both player and developer alike. Unfortunately, there seems to be a lot of lack of real understanding of what an engine is below the surface and the significance of the game engine, and you'll often see engines thrown under the bus for poor game design or when an engine is just plain misused. I've seen a good number of gamers refusing to even play some games based on the engine that they're developed on, especially the universal modular engines like Unity, so I wanted today to hopefully do my part in setting the record straight, as ultimately an engine is very little more than a tool, and it all comes down to how you use it. In a nutshell, the engine is a framework upon which a game developer can create a game. It's the underlying code base that allows the creation of the product without creating everything from scratch every time. Generally speaking, each engine is better at doing one thing or another, but with the exception of some very specific things like the difference between 2D and 3D rendering engines, any engine can, on a fundamental level, be used to create the game that you want to make. The selection process, choosing which engine to use, really should come down to which engine best serves your specific needs, and a few other factors, which I'll talk about later. Generally speaking, when we talk about a game engine, we're talking about a suite of interconnected systems that complement one another to allow for the creation of a complete game experience. Each of the components of the game engine interact with the base level code of the computer, providing a layer of simplified and varied features for the game developer to make use of. Simplified in that it provides a unified way of defining features that is simpler than coding it from scratch oneself. An engine is by no means a simple piece of software. Collectively, this sort of program that bridges the gap between low-level code and the scripter is referred to as middleware, as it lives between the two. A game engine's primary components are at minimum a rendering engine, which is the system that displays all the images in the game, and an audio engine that's used to interpret audio data and output it to the player, including with the addition of effects like three-dimensional sound, attenuation, and so on. Tying these together is the logic engine, or simply the main game program. This provides a platform upon which the game logic and math can be applied, and frequently this also provides a visual scripting language that the developer can use to define high-level game logic and variables, called script. More advanced engines also frequently include a physics engine, which applies simulated velocity-based physics to objects in 3D space, allowing objects to fall realistically, and the ragdoll effect that's so ubiquitous in gaming now. An AI engine that facilitates the definition of behavior of things in the game that are meant to have the ability to act in a non-set pattern, or a networking component that facilitates communication over computer networks, generally for the application of multiplayer or DRM. Some rendering engines only handle 2D sprites, which are usually either a grid of pixels with colors applied, or vector, which is a coordinate-based system that renders lines between each coordinate to create polygons, essentially. In contrast to the 2D game engine, there's also 3D, which in the current era is significantly more common, even interestingly for the creation of predominantly 2D games. The 3D engine renders images on a screen based on a system similar to vectors, but with a third dimension. It includes lighting calculation, systems to optimize the rendering of the images on screen like frustum and occlusion, culling, and additional post-processing features that are intended to improve the visual quality of the image, like features you may be familiar with like anti-aliasing and ambient occlusion. In a general sense, the rendering engine is the component that gets the most attention and sort of serves as a signature for the entire engine since it's the most overt part of a game. The methods employed to render, behavior of lighting, shadows, they can be so distinct that people particularly familiar with the idiosyncrasies of each can frequently tell what game an engine is rendered using simply by looking at a screenshot. Physics middleware is also a fairly high-profile component at times, and for many years, before physics became a significant part of many of the high-profile engines like Unreal, Source, and Unity, was a business unto itself, with companies like Havok making their fortunes on having their physics integrated into other engines. And with good reason. Physics calculation mishaps can be just as bad as, if not sometimes worse than, a rendering issue. Problems with collision, objects accelerating far beyond the velocities that they should be able to, and items ragdolling a little too aggressively. They're hilarious, and they're noticeable. There's plenty of misconception about what game physics entail ultimately, as is evidenced by a large number of posts to the game physics subreddit, but that's a topic for another video altogether. Each engine has its own idiosyncrasies, but we're often so quick to blame the engine when something isn't quite right with a game. I see plenty of ignorance about the usefulness and potential of game engines based on a few cheap projects built on it. Not all developers are created equal. While there are asset flips bought right from the Unity Asset Store, there are also beautiful and varied games like Satellite Rain, Hearthstone, Hollow Knight, and Rust, all created on the Unity engine, for example. As a developer, when selecting an engine to use in the development of your own software, the main considerations that one would typically make are factors like cost, of course, though there has been a trend in the past few years of engines releasing entirely for free, with a few noticeable strings attached. And beyond cost, rendering engine and what it's most well suited to. There's a reason that Bethesda keeps using the Creation Engine, which is an offshoot of Gamebryo, as it does what they need it for. The switch from small, instanced but detailed zones to an open world necessitated also that BioWare move Mass Effect Andromeda to the Frostbite engine from Unreal, where Mass Effects 1 through 3 were created. If you're looking for scalability, though there's sadly no perfect option for a 3D engine for mobile, Unity is a pretty good choice. And if you don't have the networking chops, and can't find or just plain can't afford a networking rockstar, Lumberyard might just be the ticket. And there is of course familiarity. From project to project, having a similar development pipeline with familiar tools that your team is well trained with can save up to months of development time, which, if you remember my video on man months, you'll realize is a huge investment for unknown returns. Some engines are more user-friendly than others, and some are better for one team in a studio than others. Ask a programmer what they hate about the engine that they use, and I guarantee you that they'll have a few choice words. As a designer, I loved Unreal Engine 4 for its ease of scripting with Blueprint, while the art tools in Autodesk's Stingray give immense power to an art team. Evaluate your needs and what each engine can do for your team. A game engine is an immensely complex piece of software, so much so that in order to maintain an in-house engine of any level of quality, companies form entire departments dedicated solely to the upkeep and feature development of a game engine. Epic Games and Unity employ hundreds to keep their own engines top in class, and, if rumors are to be believed, only a few years ago the Cry engine cost literally millions of dollars to license because it was that good. And rightly so. I had a good friend who loved engine development, who spent literally months on creating a memory allocation system alone. Developers can, and I apologize for the harshness of this statement, waste years of their lives building an engine for minimal returns when an existing solution will already do the job with little compromise. Some savvy studios will buy a perpetual and unlimited license from an existing engine and improve upon it, but there's a good reason why so many games begin with a familiar engine splash screen. And now with source code available for engines like Unreal 4, there's honestly really no good reason to reinvent the wheel. And that's ultimately what engines are for, right? But that's all I have for today. I hope that you enjoyed this episode of ThursDev and that you found it entertaining, enlightening, educational, or any other positive thing. I hope that you enjoy the content that we create for you, and if you do, that you might consider subscribing to this little collective of game enthusiasts who enjoy both the making and playing of games. And that if you have a friend that you think might benefit from our videos, you share it around. That's what it's here for. We release videos every week, so please do consider dropping by again next time as well. I hope that I'll see you there. Until next time though, take care.